Hello viewers, I am Kausalya. Today we are going to solve block diagram reduction problem. This is the same problem but we are going to do it the another method. So this is example 1.16. We are going to solve by another method. So here I have named it as method 2. So reduce the block diagram shown in figure and find C by R. This is the given problem and this problem consists of 4 blocks. Finally, we have to reduce it to a single block and find the C by R. C by R is nothing but ratio of output to the ratio of input. So, this is nothing but C by R is transfer function. So, the first step here is moving the branch point before the block G1. So, here this diagram consists of two branch points, branch point 1 and branch point 2. So here what we are going to do is I am going to move this branch point 2, right? This branch point 2 is moving before the block G1. So whenever we are moving a branch point in front of the block, we have to use our rule number 4. So this is our rule number 4. Whenever a branch point is moved in front of the block, we have to include the element which is present in this feed forward path. So here, this is your branch point. I am going to move this branch point in front. That is, branch point from here moves to here. So, whenever a branch point is moved in front of the block, you have to include an element, that is the same element should be included in this branch point, right? So here this branch point is moved in front of the block G. So I am included the same G in this branch point, right? That's it. So here in this case, this is the branch point 2. This branch point 2 is moved in front of the block G1. So here when I am moving this point 2 to point 1, I have to include, now I am moving this branch point in front of the block G1, right? So I have to include a block G1 in this line. So here, this is your G1 and this sketch remains here as such, right? So this is your first step. The second one is combining the blocks in series. So here in this case, listen, now G1 and G2 are in series combination. So whenever two elements are in series, we can combine it by just simply multiplying the elements here. That is, this is our rule number 1. So here, listen, combining blocks in cascade. That is, when two elements are in series, we can just multiply the terms inside the block. So G1 into G2. Similarly, here I am having G1, G2. So when you combine these two blocks together, just you have to multiply. So here I am having G1, G2. The remaining, the G3 remains as such. And here, just in the here also I am having G1 and H are in series. So when you combine these two elements, you will be having G1H, right? So now listen carefully. This is our feed forward path. In this path there is no element. So the thing is, you have to assume a block whose value is 1 here. Okay, this is an important step here. So in this case, the next step will be here. This is the feed forward path and this is your feedback, right? And the type of feedback here is negative feedback. So whenever you are eliminating a feedback loop, the formula here is nothing but the element in the feed forward path, that is 1 divided by the same 1. If you are having a negative feedback, you have to put a positive sign plus G1 into H, right? Whenever the feedback path is eliminated, this feedback loop when get eliminated, we will be getting the term like this, right? Hope you all understand this one. This is our rule number 10. That is, this feedback path gets transformed like this, right? And the next step is here, this block and this block are in parallel combination, because here G1, G2 starts with this point and ends with the summa. This summer is nothing but S2. And similarly, G3 also starts with this point and again it gets ended with the same summer. So these two elements are said to be in parallel combination. Whenever blocks are in parallel, we have to use our rule number 2. So here rule number 2 is nothing but whenever blocks are in parallel, just we have to add those elements inside the block. That's it. So here in this case I am having G1, G2 and another one is G3. So when you add these two elements, you will be getting G1, G2 plus G3, right? And here this feedback loop gets eliminated, gets reduced like this. So here I am writing this expression here. That is 1 divided by 1 plus G1 into H, right? Now these two elements are in series, right? So whenever elements are in series, we have to just multiply these two elements. So when you multiply, your expression will be 1 by 1 plus G1H multiplied by G1, G2 plus G3, right? So when you write the transfer function, you can write C by R. That is, output by input is nothing but G1, G2 plus G3 divided by 1 plus G1 into H. This is our required transfer function. This transfer function can be obtained by two methods. Now we had obtained by using method 2. Even in method 1 also we will be having the same expression. So I have taken this problem just to show you that a same problem can be solved in different ways, but the final answer always remains the same, right? That's all. The problem gets over here. Thank you.